Howdy folks, and welcome to today's video, which is all about joining, also known as merging, multiple data sets into one in Microsoft Excel. So when you're working with data in Excel, or most any other platform for that matter, a very common task is combining columns of data from multiple data sets into a single consolidated data set. Now, in a SQL database, just for example, we would accomplish this using joins. But in an Excel spreadsheet, we would typically resort to that most infamous of functions, the legendary VLOOKUP. Or perhaps its newer and improved sibling, XLOOKUP. The problem is, however, if your data happens to be in Excel, or a SQL database isn't readily available for you to use for these kinds of operations, VLOOKUP and even XLOOKUP are honestly kind of clunky at best when it comes to this sort of operation. Just for example, while there are multiple types of joins in SQL that allow you to specify exactly how columns from multiple data sets will be merged together, for example, inner joins, outer joins, and so on, VLOOKUP and XLOOKUP pretty much just work one way. For another thing, using these functions to bring in new columns from a secondary dataset requires that you write a formula for every individual value you fetch from that dataset. And these formulas can become increasingly unwieldy and performance heavy as the size and complexity of your data grows, which often leads to convoluted formulas that are difficult to maintain and troubleshoot. But fortunately, there's a better way that doesn't require you to, install a database on your computer. And that is Power Query. So Power Query, if you're not familiar with it already, is a robust, user-friendly tool built right into Excel that offers a far more efficient and flexible approach to combining and transforming data than traditional formulas. Power Query effectively bridges the gap between spreadsheet functionality and database-like operations. Now, Power Query can actually do a lot more than just merging columns from multiple different datasets. In fact, it's a complete ETL, or extract, transform, and load tool, but we'll be focusing on one particularly useful operation, that being merging columns from multiple different datasets, for the purposes of this video. And that operation, unsurprisingly, is called merge. So merging combines columns from two different datasets, effectively making the resulting combined dataset wider, so to speak. Merging requires that the individual rows of each respective dataset be associated or tied together in some way. That's how we're able to pull the values and columns from both datasets together in the same row. Now, this is done using a field that each dataset has in common, often some kind of ID, but also quite commonly a date or even a name. Now again, if this sounds anything like a VLOOKUP or XLOOKUP function to you, you're right on. It basically is, albeit a more powerful one, with far more options for customization. And to that, the example we're about to walk through is going to demonstrate how merge operations in Power Query can be a superior alternative to VLOOKUP and XLOOKUP, especially when you want to pull in more than one field from your second dataset. So for our example in this video, we're going to be combining columns from two distinct datasets in the Excel spreadsheet you see here. On the first tab of the spreadsheet, we have a dataset pertaining to home sales, in which each row, each record of the dataset, has information about exactly one home sale. Things like the address of the home, the city and state it's located in, the square footage, the asking price, the sale price, and so on and so on. Next up, the customer data worksheet in this spreadsheet contains information, not surprisingly, about customers. Those customers being the people who are actually buying the homes listed on the home sale data worksheet. And much like with the home sales data set, each record on this customer data worksheet has information about a single customer. For example, their phone number, age, income, and so on. Now, if we go back to our home sale data set, we see that we have a customer ID column and a customer name column, but really no other information about customers. So our goal here will be to create a single combined data set that has all the fields you see here pertaining to home sales, but also includes additional fields from this customer's data set, all in a single place. Now, the key to this whole operation, both literally and figuratively, is going to be this customer ID column, which we see in both the customer's data set and the home sale data set. This field is how we're going to associate individual rows between these data sets with each other. So take, for example, the first customer listed in our home sale data set with customer ID 208. If we flip back over to our customer data worksheet, we find on row 8 this very same customer ID. So in our final output, these values for this particular customer, this email address, this phone number, this age, this income, will be added on the same row as that same customer ID from our home sale data set. Okay, so now that we understand what we're trying to do here, let's go ahead and fetch this data into Power Query. And the great thing is, it's easy, like crazy easy, to load data from our current Excel spreadsheet as opposed to an external spreadsheet, which is something you can do, but that's a topic for another day, into Power Query. Now, as a first step, you need to make sure your data is structured as an Excel table. So in case you're not familiar, Excel tables are an extremely cool feature that, among other things, allow your data sets to automatically expand to include new data, offer consistent formatting, and provide easy-to-use filtering and sorting capabilities, among other things. All of which makes data management a lot more efficient. Now, the many features of tables is a topic in and of itself, but all we need to concern ourselves with here is simply converting our data sets into tables. And to do that, all we have to do is first select the data set, which I'll do by clicking in the top left cell and then hitting Control-Shift right arrow, Control-Shift down arrow. And then I'll use the keyboard shortcut Control-T to tell Excel that I want to convert this data set to a table. Now, our table here does in fact have headers, as the vast majority of data that you would want to convert to a table should, so we'll leave that option checked and then click OK. And then, as a best practice, to make our table easier to reference going forward, I'll change the table name from the default Table 1 to something more descriptive, like customers. And just like that, our customers' data has been converted to a table. And now that we see how that works, converting our home sale data set to a table should be a breeze, right? So once again, we do Control-Shift right arrow, Control-Shift down, Control-T, OK. And I'll name this table Home Sales. OK. So with both of our data sets freshly converted to tables, let's turn our attention to pulling those tables into Power Query. So we'll start by making sure we've clicked anywhere inside of that table to ensure that it's selected. Then we'll hit the Data tab on the Excel ribbon. And then, over in this Get and Transform Data section of the Data tab, we'll hover over these icons until we see one with the caption from table/range. So now if we click that button, now, just a few seconds later, our home sales dataset has been loaded into a table in Power Query. And as you can see, the Power Query environment is completely distinct from regular Excel. It has its own menu and its own set of options. And that means this dataset is now available for us to work with using the vast array of tools Power Query has to offer. And believe me, that array of tools that Power Query can bring to bear in your data truly is vast. But again, while it's true that you can do all sorts of things with your data once you've loaded it into Power Query, to keep the duration of this video under a week, we're going to keep our focus on that merge operation we talked about earlier. But before we start merging, we first need to effectively save this data set to Power Query. And to do that, we'll hit the down arrow under this Close and Load button, and then we'll choose Close and Load To tell Power Query exactly where and how we want to load the data. So here in this next dialog box, we'll select Only Create Connection. This keeps the data available for us to work with in Power Query, but also avoids exporting that data back into our spreadsheet. So now let's click OK. And just like that, our home sales dataset has been saved as a table to Power Query. So now let's follow the same steps to get our customers dataset into Power Query. So again, we'll click anywhere inside of the table to select it. And on our Data tab, we'll go over to the Get and Transform Data section, and then click our From Table Range button. And now that our customers dataset has been successfully loaded into Power Query as well, one other thing I want to point out is that the names that Power Query assigned to these datasets are the same names that we gave the Excel tables that these Power Query datasets were sourced from. So that's yet another reason to give your Excel tables descriptive names. You never know when you might want to fetch those tables into Power Query to perform some kind of heavy-duty data transformation on them. Okay, so with our customers dataset loaded, let's go ahead and save that by again clicking Close and Load To, Only Create Connection, and OK. All right, now we have both of our datasets saved to Power Query. But now, of course, we're back in Excel. So how do we get back to Power Query? Well, it's actually quite simple. Still on the Data tab of the Excel ribbon, and still in the Get and Transform Data section, we'll click this down arrow under Get Data, and then choose Launch Power Query Editor, which, naturally, does exactly what it sounds like. So now, at long last, let's get to the real reason we're here: merging these two data sets together in Power Query. Now, the first step will be to select one of our two data sets as a kind of primary data set that we will merge the other secondary data set into. Now, it honestly doesn't really matter in terms of our desired output which data set is which. A big distinction versus using VLOOKUP or XLOOKUP, by the way, but I generally think of the secondary data set as the one I'm pulling additional columns from, and the primary data set as the one I'm adding columns to. If, of course, that framing makes sense for a given scenario. Now, in our current situation, I think the home sales data set makes sense as the primary data set that I will merge fields from the customer's data set into. So I'll select it over here in the Power Query editor. And now, on the default Home tab of the Power Query ribbon, I'll click the arrow next to the Merge Queries button. And then, from the two options listed, we'll choose Merge Queries as New, so that instead of overwriting either of our existing datasets here, our new creation, consisting of columns from both the home sales and customers datasets, will get its own dedicated table. So let's go ahead and click this. So in this next dialog box, we'll first need to specify the two datasets we want to merge together, and then tell Power Query exactly how we want those datasets to be merged. Now, as you might have noticed, since we had already selected our home sales dataset, that one is already appearing at the top of the dialog box. So now we have to specify the other dataset that we want to merge into our home sales dataset. And that's obviously our customers dataset. So to specify that, I'll just click this next drop-down box here and choose Customers. Now the next step is to tell Power Query which column these two datasets have in common. That column is what we're going to use to link these datasets together row by row. So we can take the values in all the columns from both datasets for a particular ID and then combine them on a single line or row in our merged dataset. Now obviously that column is customer ID, so I'll select that for our home sales dataset, and then I'll also select it for our customers dataset. Next up, we need to specify the type of join being used. This is the method by which Power Query is going to tie these two datasets together, row by row. Now the default kind, which is the most common and which functions the most like a VLOOKUP or XLOOKUP function, is a left outer join. Now if you're familiar with SQL at all, this works exactly like a left join in SQL. Basically, our output is going to contain all the rows from our first dataset, that being the home sales dataset, and then any rows from our second dataset where there was a match on that customer ID. But if there was a customer ID in our home sales dataset that doesn't exist in our customers dataset, we're just going to see blank or null values in the columns we're pulling in from our customers data. And if you look at the very bottom of the dialog box, Power Query has already identified that our selection matches 160 out of 161 rows from our first table. Now that means that out of 161 customer IDs in our home sales dataset, there were 160 matches found in our customers dataset. So in other words, there's one missing. And in a second, we're going to see how that looks in our output. But for now, let's go ahead and click OK. And here it is, our combined, or rather merged, dataset. And now, if we scroll all the way over to the right, we don't see those columns we wanted to add from our customers dataset, but we do see a rather bizarre new column called Customers that has a bunch of values that just say table. So what does this mean? Well, by default, Power Query actually isn't going to automatically pull in all columns from that second dataset. Instead, it lets us cherry pick which ones we want to keep. So to see that list of columns that's available for us to pull in, all we have to do is click this little button to the right of the customer's column header. And now we see a list of all the columns from the customer's dataset. Now looking at these columns, we know that we already have a customer ID column in our home sales dataset, and we know that the values in the home sales dataset's customer ID column and the customer's dataset's customer ID column are going to be the same for any given row because that's how we were able to pull in the customer's data to begin with. So let's go ahead and uncheck customer ID here, since that's definitely going to be redundant. But I think I'll actually keep the other 4 columns. And now, before clicking OK, I generally like to uncheck this Use Original Column Name as Prefix option. If you leave this checked, then the names of the columns you're fetching in from that secondary dataset will be prefixed with the name of the dataset. So instead of an email column, you'll have a customers.email column. Generally not what you want. This is included as an option in case you're pulling in fields that have the same name as fields from your primary dataset. So that prefix would be a way of distinguishing the source of the 2 fields. But in our case, and I would say in most cases, as long as you're strategic about which columns you're pulling in, those columns probably don't overlap with the columns in your primary dataset. After all, that's why you're pulling them in the first place. So let's go ahead and uncheck this and then click OK. And then scrolling over, sure enough, there are our new columns. Now contrast what we did here with VLOOKUP, which, while it does something similar, would require you to write a column full of VLOOKUP formulas for every single column of data you want to pull in from your secondary dataset. Yuck. But there's one thing I don't want to lose sight of here. What about that ID from our home sales dataset that was missing from our customers dataset? Well, if we scroll down through our data here, all the way down in this last row, we see the word null in all 4 columns from that customer's dataset. But if we scroll across to the left, we have normal data values from our primary home sales dataset. So this is an illustration of how that left outer join we chose handles cases where the value we're using to tie the 2 datasets together exists in the primary dataset, but doesn't exist in the secondary dataset. Now, there does happen to be another way to handle this scenario, which you're probably familiar with if you have a background in SQL, and that's called an inner join. Now, with the inner join, if a match isn't found in the secondary dataset, the rows simply won't show up at all. So the only difference between what we did here and the inner join is that this last row that has nulls from our customers dataset and values from our home sales dataset would not be here at all because there was no match in both datasets, specifically no match in the customers dataset. And just to prove that to you, I'll actually modify our merge operation here by going over to the Applied Steps pane on the right side of the Power Query editor and then clicking the gear icon next to the first of those applied steps, that being the one that created this merged dataset to begin with. And sure enough, this brings up the same dialog box we used to specify the 2 tables involved in our merge operation and how we wanted to join those tables. But now, instead of going with a left outer join, I'll choose an inner join. And then before I click OK, take note of the fact that Power Query is telling us that the selection matches 160 of 161 rows from the first table. So we know that our unmerged primary dataset has 161 rows. So now if I click OK, looking at the very bottom of the screen, we see that the merged dataset only has 160 rows. And then to see our columns from the customer's dataset expanded once again, we just need to select this next step in the Applied Steps pane to redo that transformation we performed the last go around. So now, scrolling across, If we go all the way down to the bottom of our data set once again, we see that that row of data that had nulls from our customer's data set is gone. And gone with it is the row of data from our home sales data set, which had the customer ID that was missing from our customer's data set. So now you might be wondering, which of these techniques, left join versus inner join, should you use? Well, from my experience, the vast majority of the time, the left outer join is what you'll want. Because normally you're perfectly content to pull in whatever matches happen to exist from a secondary data set, but you don't want to lose visibility into any of the rows in your primary data set. But if your situation does call for only returning rows where there's a match on both sides of that join, then inner join is what you'll want to opt for. Now, it's also important to note that by no means are we limited to just inner joins and left outer joins in Power Query. There are actually several other, somewhat less commonly used join types that can handle unusual scenarios or edge cases, which underlines the point that Power Query is a robust, professional-grade tool that can accomplish many data transformations that were previously only possible using database software, and in some cases even more. Now, the scope and breadth of Power Query's functionality is such a massive topic that it's really more appropriate for an entire course rather than one video. And in fact, I created just such a course. Pardon me for the shameless self-promotion. But for now, I would simply encourage you to explore the various options Power Query gives you to combine and transform data. I suspect you'll be surprised at the kinds of things you can do with just plain old Excel. Okay, so with the majority of this tutorial all wrapped up, all that's left to do is put a bow on it by exporting our merged data set back into Excel. And to do that, I'll again click under Close and Load, and then Close and Load to. But this time, instead of choosing Only Create Connection, I actually want to tell Power Query to push our merged data set into a new table. So I'll leave this Table option selected, and then click OK. And then closing this Queries and Connections pane over on the right and scrolling across, there we have it. Our combined data set with all the columns we want from both our home sales data set and our customers data set in one place. And without having to write a single formula. Pretty daggone cool, I'd say. All right, folks. So that's it for this video. As usual, if you enjoyed it, please give it a like and let me know in the comments. And maybe even subscribe to my channel if you want to be the first to know when I drop a new video. All right, have a great one.